right, boys and girls, today is Friday, May 1st, and we are going to talk about classifying triangles based on their angle measurements. So the first thing we're going to do is review some vocabulary to set us up for success. So remember that, first, title at the top, angles of a triangle, or classifying triangles based on angle measurement, and the date is Friday, May 1st. Okay, so congruent means the same, and you might have encountered that in your workbook already and figured that out. Just to clarify, if you see the word congruent, that means the same. If you look at an example and it wants you to notice the congruent sides of a triangle, it's asking you which sides of the triangle are the same, which ones are the same length. Okay? Next is parallel. Something that's parallel will never run into the other thing. So if I have two lines that are parallel, maybe you could find that in a rectangle or a square, those two lines should never intersect. If I keep drawing them, they will just go right alongside each other forever and ever. Perpendicular is the opposite. Lines that are perpendicular will intersect. They will form a 90-degree angle where they intersect. Okay. Next, we're going to talk about angles. So the terminology you need to understand is acute, right, and obtuse. An acute angle, and we're going to use a protractor. If you have one at home, go ahead and take it out. You're going to need it. Or on the resources in the workbook, they also have ones that you can print out. Which won't be as effective, but at least you'll have something to work with. Okay, so an acute angle is one that's less than 90 degrees. So when I look at my protractor, I have 0 over here, 10, 20, 30, 40, 50, 60, 70, 80, 90. Right at the top. And those two 90s line up together. So I'm looking at this angle right here. This to here. Right in the middle, that's 90 degrees. So an acute angle would be one that is inside of that, something that's less than 90 degrees. So it might be 85 degrees. And notice you would measure it with these numbers on the top, because the numbers on the bottom get bigger in one direction and smaller than in the other. And that'll make more sense once we start doing the examples. So if I have an angle, we'll just jump right in. If I have an angle, no, I'm going to wait. I'll show you in a second. So the next one is right. So we already mentioned that. A right angle is exactly 90 degrees. Anything in that is acute. Okay, I think we got that. Obtuse, on the other hand, is anything that's larger than 90 degrees. So it's going to be this way. Think of obtuse like obesity, something that's maybe large, or something else. I can't think of another word. Something that's obtuse is more than 90 degrees. All right, let's get into the examples after we talk about how to name the different triangles. So you might have already put this together. An acute triangle will have 3 acute angles. A right triangle will have one 90-degree angle and 2 acute triangles. And this is actually the only combination that's possible for a right triangle, and we'll go over that as well. An obtuse triangle is one obtuse angle, so a big angle, and then 2 acute triangles. All right, let's dive right in. So I have 3 triangles right here, and I don't know how to classify them. I'm going to take my first mystery triangle and my protractor. To measure it, I'm going to take the corner of my triangle. There's a little circle right in the middle. I'm going to put it right in that circle. And notice I'm not putting my triangle on the bottom of my protractor. I'm putting it on the line. There's a little bit of a line right there, and I'm going to hold it real tight. So when I look, and it's hard to do this with cardboard, when I line it up and I look at this angle on the top, I can see that it is 90 degrees. So what type of triangle is this? That's right. If it's exactly 90 degrees, it's a right triangle. All right, now that I've put aside my right triangle, I'm going to go ahead and test out my next triangle. So looking at this, I can kind of make a guesstimate of how large the angle is without knowing exactly the degree measurement, because I can look at my 90-degree angle and I put it over the top and I can see that the 90-degree angle is smaller than the other angle of my new triangle. I'm going to measure anyways, but those observations are going to make your job a lot faster. In my head, I'm already thinking what? That maybe it's over 90 degrees, so it's an obtuse angle. Okay, well, let's check it out. So I have my triangle, and I'm going to put the bottom line, bottom line on the bottom, lined up with that little dot, and I'm looking at this over here. So, what am I at? We're looking at, oh, I see two numbers. I see one on the top that says 80 degrees. I see one on the bottom that says 100 degrees. That's confusing. Well, I know it has to be more than 90 degrees because it's more than a right angle. And it's extending to that other side of the protractor where there's two sets of numbers. And I need to remember that knowing that it's greater than 90 degrees, I'm going to use the measurements on the bottom for those obtuse measurements that are larger than 90 degrees. Does that make sense? Okay, takes a little getting used to, but keep practicing. So looking at this, I am right at about 105 degrees, between 100 and 110. So it's greater than 90 degrees. That means we have what kind of triangle? An obtuse triangle. Awesome. Okay, I'm going to put it over here. And I have one more triangle to test. I'm going to line my angle up. And by the way, guys, it doesn't matter what angle you start with on your triangle. Just put the corner on the side and remember what corner you tested, which is easier in some triangles than others. So I have my corner in the middle, my line of my bottom border of my triangle on my line. I'm holding it as carefully as I can, and I'm looking up at this top edge, and I can see, ooh, it's a little under 70 degrees. It's between 65 and 70 degrees. I'm using my best guess. I'm going to say about 68 degrees. Okay? All right, so 68 degrees, is that exactly 90 degrees? No. Is that more than 90 degrees? No. It's less than 90 degrees. Just to be sure, let's check the other angles. So knowing this is, I know that this is an acute angle. And I'm going to see if the other angles match up too. So I go to my next point, line it up on the bottom. Oh, and this one is right between 60 and 50. So I'm at 65. Okay, so my first angle is 68. Second one was 65. Let's go to the third one. Line it up on the bottom. And this one is at 65. Okay, and know that if these are perfect triangles that were cut with a real machine and not some scissors that I stole from my mom, you would have more exact measurements and you wouldn't have this funky cardboard stuff. So be flexible with yourself, but this will give you an indicator of how you need to classify it. So I have three acute angles on this triangle, and that means it is an acute triangle. All right, boys and girls, and the last thing I want to call your attention to about triangles before we move on to volume is this mysterious thing about triangles that isn't actually in my notes yet. Okay, so let's go back to our right triangle. So I will take mine here. I know it's my right triangle because it has that 90 degrees. I know that's 90 degrees, so I'm going to leave that corner alone. I'm going to go to the next one. Okay, so sometimes I have to start from the top just to orient myself. So that's my 90 degrees. I'm going to turn it around here. And just to keep track of my brain, I'm going to write 90. Okay, so there's our 90 degrees. And here on for this measurement, we have 60 degrees. Okay, interesting. I'm going to write 60 degrees down. And then for our last one, and I'm just going to keep tilting like this because it helps me really keep track of what I measured and what I haven't measured yet. So my corner's in the middle, right on the line, and I have right about 30 degrees. So here's what's cool about triangles, and will help you maybe solve triangle, angle mysteries in the future, is that all angles of a triangle should add up to 180 degrees. So let's see if it was true here. We have 90 plus 30 plus 60. Well, I grouped 30 and 60 together. I know that equals 90. 90 plus 90 equals 180. So knowing that the angle measurements of all triangles will always be 180, you can solve a lot of triangle mysteries. So for example, if you just know the angle measurement of one or two of the angles, but not the third one, knowing that the total measurement will be 180 degrees will allow you to solve that problem. It'll allow you to figure out the angle of that triangle. Okay, so let me know if you have any questions, and good luck with your homework.